This is 4.2. We're going to do 4 more parent functions. This whole first page is going to be something where you should just pause and copy the functions onto your paper. 1 over x, negative 1 over x. Make note of the domain and range. Domain x can't be 0. 0 in the denominator, no good. And there is no value that you can plug in for x that is ever going to make y equal to 0. So that would be your range. Pause, write it down. Okay. The next 2 parent functions, 1 over x squared, negative 1 over x squared. Again, the domain, x can't be 0. There is nothing that you're going to plug in for x that is going to make y 0. The difference between these 2 functions and the previous is that the whole graph exists in the positive y quadrants. The whole graph exists in the negative y quadrants. Okay. Here we go. Negative 2 minus 1 over x plus 1. Pause for yourself as needed. This is the same thing as the f of x equals negative 1 over x plus 1 plus 2. So this is the parent function with this way and that way. That's the parent function, and it goes through the points 1, negative 1, and negative 1, positive 1. There's so many ones. The parent domain and range, x cannot be 0, y cannot be 0. That's the domain and range for the parent. Okay, well, you already know how to do all this. This is a shift left 1. What value of x makes that 0? Negative 1. And what happens with that plus 2? That's up 2. This is no different than if I had given you x plus 1 squared plus 2. It's a parabola, left 1, up 2. The absolute value of x plus 1 plus 2. Again, that's left 1, up 2. The first one here is a parabola. This is a v. Okay, well, the difference now is we have a rational function with branches. Now, because I've shifted left 1 and up 2, I have changed my domain and my range. So normally we say x can't be 0, but now we're going to say x can't be negative 1. Normally we say all real numbers, y not equal to 0. Now we're going to say all real numbers, y not equal to 2. 2, that's here. Okay, so normally we say it goes through 1, negative 1, and it goes through negative 1, 1. So I'm going to kind of just look at this as I've shifted my origin. Normally my origin is at the 0. Well, now I've moved that left 1 up 2. So from here, 1, negative 1, which really in the big picture is 0, 1. And negative 1, 1, which really in the big picture, I believe is negative 2, 3. So this is 0, 1, negative 2, 3. 1 point is fine. 1 point is fine. Okay, next one, pause. So this is the parent. That's the parent. So this is going to be a shift right 3, up 1. Normally the domain is all real numbers, x not equal to 0. So now my domain is going to be all real numbers, x not equal to 3. And normally my range is y is greater than 0. Now my range is going to be y is greater than 1. Okay, x cannot be 3. Y is greater than 1. Okay, parent points for this particular function. I should have written this down, sorry. 1 over x squared is the parent. Okay, so my parent points are 1, 1, negative 1, 1. All right, but the problem is, great, I'm shifting this right 3 up 1, but I have to take care of that 2. I have to take care of that 2. So normally it goes through, where are we at here? 1, 1. Now it's going to go through, multiply your y values by 2. So now, right here, 2 over x squared. This is now going to be 1, 2. Negative 1, 2. I took the parent points. I multiplied my y values by 2 because the numerator is 2. So 1, 2 is from my new origin, 1, 1, 2. Which in the big picture is 4, 3. Negative 1, 2. So from my new origin, negative 1, 2, negative 1, 1, 2. Oh my Lord, that is just about as bad as a graph as I've ever seen. That would be 2, 3. There are a lot of ways you can do it. If you don't like my whole new origin way, that's fine, but really got to break the habit of like making an XY table because that's not good. Okay. Pause. Here's the next problem. Find the domain. Domain is all about X. Domain is all about X, and in a rational function, it's all about the denominator. Denominators. Logs, arguments, and in roots, the radicand. Arguments, radicands, denominators all cause problems. I don't care about the numerator. I do not care about the numerator. I only care about the denominator. So I'm going to set it equal to 0. I'm going to find my bad issues, which will become asymptotes or removable discontinuities, depending. So I believe this is I think that's how it factors. Yep. This is all real numbers. X not equal to 1/3 or negative 2. We'll be graphing this in the next section. Don't worry. Removable discontinuities, oblique asymptotes, horizontal asymptotes, all that good stuff. Okay, pause for yourself. Okay, I don't care about the x minus 3, at least not right now. When it comes to the domain, we don't care about the numerator. We care about the denominator. So x to the 4th plus 1 equals 0. And we're good. There's no value that you can plug in for x that's going to make this whole thing 0. X to the 4th equals negative 1. Nope. The domain is all real numbers. We'll be graphing these in the next section.